Floating mats of reddish-brown seaweed in the Atlantic Ocean have been reported since the time of Christopher Columbus. Sailors created legends, fearing they would be entangled and dragged down to the ocean floor. Patches of floating seaweed, common to the Sargasso Sea, have multiplied into a giant Sargassum Belt.
It's spanning almost the entirety of the tropical Atlantic.
This is an entirely new oceanographic phenomenon.
Just so much larger than any other macroalgae bloom in general on the scale of an entire ocean.
Its length this year has reached a whopping 5,000 miles.
Is way bigger than any year before.
At sea, Sargassum is a natural wonder, a protected habitat. But when it washes up, this living algal bloom rots on the beach and turns toxic.
When sargassum is offshore, it provides essential fish habitat and critical habitat. However, all that changes when you have excessive amounts of it coming ashore, where it sits and it begins to rot, decompose, and release toxic hydrogen sulfide gas.
Driving away tourists and threatening the local fishing industry.
Boats simply cannot get through, lessening the number of fish that they can actually catch, directly affecting their and their families' livelihoods.
This is a crisis in the Caribbean region. Its impact on tourism has really been catastrophic.
Can't deal with it. And we can't leave it on the beach because the tourists don't like it. No one likes it. It stinks.
The Sargassum Belt is so large, it's visible from space.
Satellites are the way that you can actually adequately capture the sargassum blooms.
Scientists are racing for answers as to how to protect coastal communities while also tracking and safeguarding this natural wonder at the same time.
This floating sargassum is a barometer of global change in how humans are altering the nutrient cycles on our planet.
This is such a pressing societal problem. We need science to deliver the answers.
The Sargassum Belt may seem like a stinky blob from hell, but it's actually a rich ecosystem.
It is not a blob, okay? By any means, it's not a blob. It's a belt. It's a continuous belt from West Africa to Gulf of Mexico.
For centuries, sargassum has occurred naturally in the Sargasso Sea, which owes its name to the seaweed.
Sargassum is this unique feature that supports a tremendous biodiversity in the North Atlantic Basin.
Yet in the past decade, an alarming trend has surfaced. The sargassum is originating in new areas, Eastern Atlantic and Western Atlantic.
The Great Atlantic Sargassum Belt really starts off the west coast of Africa. We consider that to be a new source region prior to 2011. We had never seen sargassum growing in that part of the tropical Atlantic Ocean.
This is a new phenomenon. It was not there before 2011.
A virtual floating island habitat and refuge for many important species.
Sargassum contains hundreds of species of fishes and invertebrates. It's often compared to tropical rainforests in terms of its amazing biodiversity.
Many of the sea creatures that live and spawn in the sargassum are endangered. 10 species live nowhere else but here.
Sargassum is a critical habitat for many marine animals. So that's good for ecology. But most people from land would view sargassum as a beach nuisance because that's what they see. They don't see sargassum in the open ocean.
The mass is so large, it has nowhere to go but wash ashore by the ton. on some of the most popular tourist destinations, wreaking havoc.
You have all these problems when you have excessive amounts of sargassum coming ashore, ranging from toxic hydrogen sulfide forming because of these dead zones.
Dead zones that contain plastic debris, which, when combined with sargassum, could create a perfect breeding ground for deadly flesh-eating bacteria.
We're seeing algal blooms, for example, in Florida following the decomposition of sargassum that we had never seen before.
Keeping the sargassum offshore is one solution, but ultimately, scientists must figure out the source of this new phenomenon if they're to get ahead of it.
One of the key questions that we're trying to answer is, where are the nutrients coming from to fuel this massive profusion of sargassum in surface waters?
With satellite and remote sensing technology, optical oceanographers are able to provide a view from above.
The reason to use satellite data to detect this is it's the only way to actually view the entirety, the scope of this thing, and we have measurements on a daily basis. You could never get that, even if you had thousands of ships out in the ocean trying to collect data.
These eyes in the sky not only provide a wide view, but with remote sensing technology, they can determine what type of object they're looking at.
In the remote sensing of sargassum, that is using satellite data to image the surface of the ocean, and through very, very detailed algorithms back out the percent of the ocean surface that's covered by sargassum.
It really helps us see the movement, for example, of sargassum seasonally from the Gulf of Mexico around the Florida Keys and up the east coast of Florida into the northern Sargasso Sea area.
This has been a revolutionary data set to be able to understand the distribution and variability of sargassum, and now provide us a basis with which to test models of how this system is working.
This valuable satellite data recently provided scientists a window of opportunity, as they were alerted about a research vessel that would be heading straight through the Sargassum Belt.
The global research community has this wonderful program called GoShip, which samples the ocean over very long transects in all the basins of the ocean. So I had been following the ship's schedule. We realized very early on that some of the transects that the GoShip program would be doing would be ideal to study the sargassum problem, and asked for a berth. And they said, well, our berths are all full, but there are some really bright students that are going on this trip, and they may be willing to volunteer their extra time to do this.
Dr. Dennis McGillicuddy mentioned that we would be going through the Sargassum Belt and asked us if we had the opportunity to collect samples and preserve them for him and his collaborators. While we were at sea, we were receiving the satellite updates of the spread of the Sargassum Belt.
We provide satellite imagery in near real time, almost every day, to the group out at sea, so they can find sargassum easily.
Everyone was really excited and kept waiting for the sargassum to show up, and we saw a few little bits float by at night. And then once the sun came out, we realized that these were actually large patches of sargassum that were spreading across the horizon.
This serendipity helped to form a consortium of oceanographers by combining all different backgrounds to tackle the sargassum problem in an entirely new way.
Because the ocean is very large, there's very few opportunities to take measurements. It was kind of amazing to see these large patches predicted by satellite in person, because you are in the middle of the ocean.
At sea, you can't see very far away. You can't find this. So we provide real-time support. And in turn, they collect the sargassum to analyze the sample to determine what is in the samples.
It's not all that high tech. It's big long dip nets fixed to a big long pole. You dip the net in the water and scoop up the sargassum, and then the sargassum is brought on board, washed in deionized water, and then dried basically in ovens to be preserved.
We really want to know what are the nutrient sources driving the Great Atlantic Sargassum Belt. In order to sustain an algal bloom of this magnitude, you have to have a large nutrient supply. These algal blooms cannot form without nutrients to grow. And we really have very little data from that part of the Atlantic Ocean. So these ghost ship cruises have given us this opportunity for the first time to get tissue data of sargassum. In the marine environment, it's typically nitrogen rather than phosphorus that limits algal growth and the formation of harmful algal blooms. Tissue data is highly valuable because the tissue really gives you a window into the status of nitrogen and phosphorus in those plants.
What the team has discovered is an evolving and significant change in sargassum chemistry.
What we're now finding in our research through this tissue biogeochemistry is that the nitrogen is going up in the oceans faster than the phosphorus. We not only saw a 35% increase in nitrogen, but over 100% increase in the nitrogen to phosphorus ratio. And this is because our population is growing so fast and we are producing more nitrogen than phosphorus that is getting into the oceans. And to me, that was just an awakening, kind of a rude awakening that immediately made me think of the major rivers, because we know as humans we're adding more nitrogen than phosphorus from our watersheds into the rivers and into the oceans. And then I began to think, this floating sargassum is a barometer of global change in how humans are altering the nutrient cycles on our planet.
Other surprises have arisen in the chemical makeup.
Some of the revelations we've seen this year, just recently, would include the high levels of arsenic we're seeing right here in the Florida Keys, over 100 parts per million, which we were thinking we would see somewhat lower levels. So that is one kind of big moment when we got those data back from the laboratory to see that.
The physical contact with arsenic is really not the issue. The issue is if it's used for, say, fertilizer or feedstock or other things that sort of could propagate up the food chain and be a threat to human health. We want to understand where that arsenic is going to wind up and make sure that human health is protected.
Ultimately, a new understanding of sargassum's evolving chemistry, coupled with advanced technology, is leading to better prediction.
From the satellite perspective, really what's emerging is integrating much higher resolution satellite sensors.
With the new satellite technology, the commercial companies have constellations of small satellites that can cover each individual beach every day with very high resolution. This is equivalent to flying a drone on your beach every day. And we are so excited about this capacity. We have a better way to predict when and whether this amount of sargassum in the water can get on the beach by combining winds and tides.
So the knowledge of surface currents and winds provide us with the tools needed to predict where the sargassum that is here today is going to be tomorrow. The physical dynamics of the ocean plays a big role in where the sargassum goes over time.
Yeah, I think that's going to stay with it nicely.
Yeah, that's a huge mat.
Another new tech tool is also aiding in tracking the floating sargassum. Drifting mats armed with GPS tracking devices.
It's critical to have as much information and with enough lead time so that you can stage and perform some mitigation activities before it comes ashore and becomes a problem.
We want to have a better prediction to inform people, to inform citizens, to better prepare for sargassum inundation.
Florida's Miami-Dade County spent $6 million to clear sargassum from 4 beaches, a drop in the bucket to what experts believe will be the impact this year.
Increasingly in South Florida, we're seeing it up to 5 to 6 feet high on the beach. And a beach raker is not going to be able to deal with that.
Innovative solutions are being used to keep the sargassum offshore.
One of the actions they have taken is to put booms out along the beach to hold the sargassum off the beach. And those booms work better when you harvest the algae.
While the science community has obtained a much greater understanding of sargassum, entrepreneurs and ecologists are discovering innovative ways to take advantage of seaweed influx and transform it into sustainable products.
How can we repurpose sargassum? Because we might be able to mitigate it somewhat, but it's not likely we're going to make it all go away.
Companies like Green Key in Tennessee are looking at sargassum as a potential source to replace plastics with nanocellulose.
Sargassum is out there in mass and can be harvested for a variety of beneficial purposes for mankind. Instead of plastics, we're going to be able to use sargassum.
Integrating the local communities and transforming this problem into opportunities for job creation, not only at a local level, regional level, but also at a global level.
I'm just really impressed to see all of the ways that people are trying to deal with the downstream problem. To me, that is extremely innovative in the whole, all that's being done to address the problem.
In addition, research that originated during the 1980s energy crisis is being resurrected.
Looking at this as a marine biomass source for energy production. By doing this, we can chip away at the use of fossil fuels, and we have massive amounts of it.
The National Renewable Energy Laboratory, or NREL, is currently funding research that could turn seaweed into jet fuel and materials used in batteries.
I think this is such a big eureka moment, not just for me, but for our planet.
Collaboration is the key to solving real-world problems.
Collect the samples, analyze the content of the sargassum, and we apply the satellite images to extend what they see from just a few samples to a large picture.
To see the big picture and understand how this system is working in the North Atlantic Ocean, you have to have a multidisciplinary approach.
These collaborations, they are, one of the beautiful parts of science is that when there is a problem or when there is a topic of interest, you can get disparate viewpoints, get disparate specialities together and solve a complex problem. We are satellite oceanographers. We don't deal a lot with hands-on nutrient analysis and the different critters.
Well, it's such a rich and complex problem involving physics, biology, and chemistry. There's no single individual that can cover all of those aspects.
I believe it is a breakthrough. I've never seen this level of collaboration on these various disciplines work as beautifully as it's working in the study of the Great Atlantic Sargassum Belt.